Hi, it's David here. Welcome to your lesson on halving numbers. Let's start with a brain teaser. Freddy the Frog is trying to leap across his pond. His pond is 512 meters long.
Hang on a minute. You can't have a pond that's 256 meters long. It's far too long. It's more like a great big lake.
It's all right. Never let realism get in the way of a good maths problem. Dear me. As I was saying, Freddy the Frog is trying to leap across his pond. His pond is 512 meters long. On his first jump, he must be some kind of bionic frog because he manages to leap all the way into the centre of the pond. But he's so exhausted after his first leap that his second leap, he can only leap half as far as the time before. And his third leap, he can only leap half as far again. So every time he leaps, he can only go half as far as the time he leaped before. And my question is, how many leaps will it take for Freddy to get across the pond? Now, some of you may already have spotted that there is a catch. So the first thing I want you to do is talk to your brother, sister, mum or dad about what you think the catch is. Pause the video, and then when you've had a little conversation about it, come on back and I'll explain. Pause the video now. Did you spot the catch? The catch is, if you halve a number and halve it again, the number gets smaller and smaller, but you will never quite get to zero, because no matter how small the number is, you can always halve it again. Even if you're left with one tiny little atom, you could still split that atom. So we need to do something to make the problem solvable. So what I'm going to say is, when Freddy is a meter from the end, he can then jump to safety. So what I want you to do now is have a go at solving the problem. In a moment, Freddy's going to do some comedy dances and pull some faces at the camera. Pause it at any moment and then solve the problem. Get as far as you can. What I want you to do is to look at the apparatus that you've got, draw lots of pictures, do lots of calculations. Don't just talk to someone about the problem, but actually show someone how the problem can be done. You don't have to solve the whole thing, just get as far as you can. When you've got as far as you can, then head back and I will give you some hints and tips to help you solve it. Before you go, if you want to make the problem easier for yourself, then rather than having a pond which is 512 meters long, just have a pond which is 16 meters long, and you'll find that much easier, and you could probably solve that with just the apparatus that you've got. If you want to make it more difficult, then have a whopping pond length of 1 meter! Has he gone mad, I hear you cry? 1 meter? That's not very hard. However, you can only let Freddy jump to safety when he's 1 centimetre from the end. Have a go at that and you'll see why it's a little bit more difficult than the others. So get ready to hit pause, have a try at the solution. I'll emphasise again, use apparatus and drawings and calculations to show how it's done, and when you've got as far as you can go, hit play and I'll give you some tips of how to do it. Okay, good luck, here we go. So hopefully you've had a really good attempt at solving the problem. I'm now going to give you some tips on how you can halve numbers. Let's have a look at how you can go about solving the problem. First of all, I'm going to be looking at the solution if your lake was 16 meters long. If you did the blue problem instead, then fast forward to the section with the blue pen and you'll be able to see that solution. And if you solve the red solution, then fast forward to when I'm using the red pen and you can see that. But first we're starting with 16 meters. Now the easiest way of doing this is actually going to be to count out 16 discs. And we're going to be finding half of this number. Interestingly, finding half of something is exactly the same as dividing it by 2. In fact, notice how similar the fraction is to the division sign. The division sign is literally one dot above another dot, and a fraction is a number above a number. So all the dividing sign is showing you that you can put any number here and any number here. So fractions and dividing are the same. So we're going to find half of 16. So I now need to move these coins so I've got the same number on each side. There you go. And now you can see that half of 16 is 1, 2, 3, 4, 5, 6, 7, 8. And it's 8 meters because the pond was 16 meters long. Another way of halving small numbers very effectively is to use a number bead. You can only use a bead string if you have numbers less than 100 to halve. But here I've got 16 beads, and look, I could just fold this bead string in half and count how many beads I have on each side. There's 8 on each side, so half of 16 is 8. Next, we had to halve 8. 8 meters divided by 2. So we just need 8 discs. With the same amount on each side. And you can see that half of 8 is 4. Now we need to find half of 4, which is the same as dividing it by 2. We need 4 discs, and we need the same on each side. And the answer is 2. And finally, half of 2 equals 1. And when your frog is 1 meter away from the edge of the pond, then it can jump to safety. So how many jumps was that? We started at 16. And then we halved that to 8. And then we halved that to 4. Then we halved that to 2. Then we halved that to 1. So the frog made 1, 2, 3, 4 jumps. Now let's have a look at the blue section. The lake was 512 meters long, so we're going to divide this lake length by 2, because half of a number is the same as dividing it by 2. Look how similar the fraction symbol is to the division symbol. All the division symbol is a fraction where you can put any number on top and any number on the bottom. So dividing and finding fractions are the same. To solve this, I'm going to show you how to do it with coins. First of all, we need to make the number 512. If we're going to halve this number, we need to find half of everything. Now that's easy to see with the ones, but the problem is we can't split the 10 in half. And also there's an odd number of hundreds as well. Let's look at the 10 first. In order to split the 10 in half, first of all I have to exchange it for 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 10 ones, which is the same as that 110, so I can get rid of that 10 now. And now I can split this 10 in half. To do that, I've just got to make sure there's the same number of ones on both sides. So half of 10 is 5. Now we need to halve 500. It's easy enough to split 4 of the hundreds in half, with 2 on each side, but we still have to split the last 100. So again, I'm going to exchange this 100, this time for 10 tens, which will be the same value, it will just look different. I can now replace this 100 with these 10 tens because it's the same value. I've just represented it differently in a way that's going to be easier to halve. Now I halve these tens by putting the same number on each side. So half of 100 is 50. So half of 512 is 256. All of these discs, by the way, still add up to 512. The amount hasn't changed, I've just changed the way I've represented it so that we can split it in half. And the answer was 256. I'm now going to show you how to represent this in a diagram so that you don't have to use the coins. This is what you can do. We're going to halve this number. This time we'll use a diagram. 256. Half of 200 is 100. And by the way, when you halve this number, call it 200, don't call it 2, because it is in the hundreds column. So it's very important that you refer to it as its real value so that you don't make a place value mistake. So here, I won't say what's half of 5, I will say what is half of 50? And the answer is 25. And what is half of 6? The answer is 3. Put it all together, how many hundreds have you got? 1. How many tens have you got? 2. How many ones have you got? 5 and 3 is 8.